We're going to start with the first planet in our solar system, Mercury. And Mercury takes 88 days to get around the sun. Mercury has kind of a dullish gray color when you look at it from Earth, but when you get closer, it more has a dark gray color, and it's thought that the only reason that it has this gray color is due to it being completely rock-based, and it doesn't have any atmosphere, and so the sun and radiation just kind of eats away at whatever color and pigmentation there may be. Venus is super cool and frankly a terrifying planet, and 90% of its spook factor comes from its atmosphere. Its atmosphere is 96% carbon dioxide, 3% nitrogen, and very little, practically none, in water vapor. But there is that tiny little bit there. This atmosphere is so thick and dense that it's, I believe, 9 times the atmospheric weight of Earth's atmosphere. And Venus is smaller than Earth, so that's crazy. Now, the atmosphere of Venus makes for some really rough weather conditions and surface conditions all over Venus. The temperatures on average are 870 degrees Fahrenheit, and it's just crazy. The wind isn't too terribly bad on the surface, but that can't be said for much higher up in the clouds. The clouds are completely sulfur, and so these clouds, when it rains sulfuric acid, which, you don't want to experience that. That is horrible for your health. But, that aside from the point, these clouds, inside of them, the winds can get up to 223 miles per hour, which is insane. Now, we don't know who exactly discovered Venus, because there is texts from Babylon in 1600 BC that depict and show Venus, but the actual discovery was given to Galileo Galilei when he observed Venus in 1610 through a telescope for the very first time. Now, Venus takes 225 days to orbit all the way around the sun, and actually 248 days to make a full day rotation. But if you were to peep at Venus from Earth right here, right now, through a telescope or from the surface, it would come out to be kind of like this yellow, maybe even kind of a white. But that's actually not the color of Venus. The color of Venus is actually a lot more grayscape. All of the rocks are different shades of gray. It's straight up like 50 Shades of Grey. But if you were to actually be standing on the surface, everything would have a much more extreme orange hue to it because of the extreme dense and thick atmosphere. And to finish it off, the gravity of Venus is actually very similar to Earth's because of their very similar size. It's actually only 91% of Earth's gravity. And so it's a very similar gravitational feel if you were on the surface of Venus. Mars, known as the Red Planet, discovered all the way back in ancient times when ancient civilizations ruled the world, but it wasn't accurately observed until 1610 when Galileo Galilei observed it. But Mars may not actually be as red as you think that it is, because yes, Mars, it appears red from Earth and through a telescope, but if you're up close to it, it appears much more of this butterscotch color. And if you're actually standing on the surface, it looks a lot more brown, gold, and tan, and that's due to the types of minerals found on Mars. Now, some areas can be white due to permafrost along with silica deposits, but that's not everywhere on Mars. And the atmosphere makes Mars appear this kind of pink-orange color. And so if you're standing on Mars, you're looking at the sky, it's kind of this pink-orange hue. Now, Mars has an extremely thin atmosphere, and it's just comprised of a little bit of carbon dioxide, nitrogen, and a little bit of argon, but this atmosphere is just 1% of Earth's. Now, with this super thin atmosphere, it makes for some extremely bad temperature changes, such as the temperatures can get down to negative 225 degrees Fahrenheit on an average night, and can get upwards of 70 degrees Fahrenheit on an average day. Now, this is just extremely crazy, but the other crazy thing about having such a thin atmosphere is even if the wind is going upwards of its fastest of 67 miles per hour, you won't feel a thing. It'll feel just like a tiny little breeze because this atmosphere is so thin that it's just like having a tiny little breeze here on Earth. Now, the average day on Mars is just about 40 minutes longer than the average day here on Earth, but the average year is 687 days, and the gravity, for some reason, even though Mars is so close in size to Earth, is only at 38% Earth's gravity. Today, we will be covering Jupiter, and Jupiter is what is regarded as the third brightest object in the entirety of the night sky, meaning it's very easy to assume that many ancient civilizations at least observed it. Now, it wasn't until 1610 when Galileo Galilei was actually given credit for the first observation of Jupiter through a telescope. Now see, Jupiter is what is known as a gas giant, and gas giants don't have any solid ground. And so that means that the entirety of the planet is pretty much just one huge thick atmosphere. But this huge thick atmosphere is built like an onion. Jupiter is like an onion. Onions have layers, and Jupiter has layers.
Okay, ogres are like onions. Oh, layers! Onions have layers. Ogres have layers. Onions have layers? You get it. We both have layers.
Now, these layers are all comprised of different varying wind speeds with various different properties, such as different temperatures, different gravities, different pressures. It's just all varying in every single different layer. But Jupiter's weather is completely different than any other planet in our solar system. With devastating storms that last hundreds of years, these storms are comprised of winds that range anywhere from 192 miles per hour to over 400 miles per hour. Okay, that's just insane. That is like 7-8 times faster than any kind of wind currents on Earth. But that aside from the point, there's this one storm that is called the Great Red Spot that is estimated to be 190 years old. This storm takes up an area of 10,154 squared miles, and that is just 1.3% Earth's entirety. So that means that this one storm could swallow the entirety of Earth. Just one go. It's all gone, which is insane. It gets even cooler than that, though. Now let's bring back those layers I brought up earlier. All of these layers are all literally just different wind speeds, but all of them have different properties, such as different pressures and different temperatures. The temperatures can range anywhere from Earth-like temperatures of anything from 80 degrees Fahrenheit all the way to negative 234 degrees Fahrenheit, which is a major swing. But the pressures are pretty much always a constant, and it's always extremely high pressure. Nothing can really sustain itself on Jupiter because of how much gravity and pressure it sustains. But that brings in my favorite fact about this planet. Okay, so Jupiter, it rains 3 different things that I could tell, 3 different chemicals. Those chemicals are methane, H2O, and every now and then helium. Now, when it rains methane, if lightning arcs through the air, what'll happen is it will have a chemical reaction turning this methane into carbon. And then carbon will get pressurized so quickly falling through the air that it will slowly turn into graphite. And then once it turns into graphite, before it goes and gets even further, it turns into diamonds. And so, theoretically, it actually rains diamonds on Jupiter. Now, we'll bring back the layers just one last time with saying that that's why there's so many varying colors. The colors on Jupiter can range anything from grays to whites, to yellows to beiges, to browns, to reds, and to even oranges. And the main thing with that is there's a lot of different subsects of those colors. And so you can see pretty much an entire array of thousands of just different shades of the same colors. Jupiter takes just about 12 full Earth years to fully rotate around the Sun, and takes just a little bit over 9 hours to fully rotate around its axis. Discovered in the times of ancient civilizations that once ruled over the world, but its first official observation wasn't until 1610 when Galileo Galilei looked at it through a telescope. But yes, you can see Saturn with the naked eye. The gravity of Saturn is somewhat comparable to that of Earth, though it is just a little bit more. So what that means is if you weigh like 115 pounds here on Earth, you'd weigh just a little bit more than 115 pounds on Saturn. Saturn takes an outstanding 29.4 Earth-year rotation around the Sun, while it just takes 10 hours and 34 minutes for it to do a complete day cycle. The temperature of Saturn can reach all the way down to negative 288 degrees Fahrenheit, with wind shears reaching 1,500 miles an hour, along with these giant great white storms known as the Great White Spots, just like Jupiter has the Great Red Spots. These Great White Spots are huge, and can get upwards of 6,213 square miles, which is just under the diameter of Earth. Earth wouldn't be able to fit in this storm, but it would just about be able to. Now, from all that I can tell, these storms don't get too much rain, but what does happen is lightning will arc through the air at least 10 times per 1 second. That's insane. Due to the contents of the atmosphere being 94% hydrogen, 3% helium, and the rest being trace amounts of ammonium and argon, Saturn kind of appears this yellow hazy brown color from Earth. Now, just a second ago, I mentioned that there's ammonia. With this ammonia, it comes in one form. That form is crystals, and those crystals form on these clouds. That's insane to me, but due to that, on the surface, it will actually appear kind of this yellow hazy color because the light is literally being refracted through these crystals. In total, there have been 4 missions sent to Saturn, and all 4 have been deemed successful. There's been Voyager 1, Voyager 2, Pioneer 11, and Cassini. On March 13th of 1781, a man named William Herschel discovered Uranus. Though he wasn't looking on Colfax Street, he actually proceeded to peer through a telescope to do so. Uranus is dubbed an ice giant because of its entire atmosphere containing high amounts of frozen particles like hydrogen and helium, plus there's also huge amounts of frozen ammonia, methane, and water on the surface of the planet, and just throughout the atmosphere. The methane actually creates the kind of bluish-green color that the planet appears as. Uranus is the coldest planet in the entire solar system, with its average temperature just being right around negative 320 degrees Fahrenheit, which is negative 195 degrees Celsius. The temperature also reaches all the way down to negative 371 degrees Fahrenheit, which is 224 degrees Celsius. Negative 224 degrees Celsius. Now, the wind on Uranus is also extremely ferocious, and the wind blows in a kind of, rotational pattern, specifically one way, and that is against the grain of the rotation of the planet, which that's just kind of cool to me. The wind can reach all the way up to 560 miles per hour, which is 900 kilometers per hour. That is extreme wind forces. Plus, these winds will also sometimes form something known as a black spot, which is similar to Jupiter's red spot. It's literally just a giant storm. But there's nothing really special about this storm, other than the fact that it got as wide as 1,900 miles. That is huge. Now for one of my favorite parts about Uranus, and that's the axial tilt. The axial tilt is actually really wonky with this planet, because if you were to look at it, it kind of looks as if like a top you just kind of started spinning, just kind of fell over onto its side. And that's Uranus. And with that weird axial tilt, during its orbit period around the sun, which is an 84-year time span, it's super cool. But every 42 years, the sun shines on a different side of the planet. And so every 42 years, each one of the poles experiences 42 years of constant light or constant darkness, which that's just insanely cool to me. The whole area that's experiencing constant light and constant darkness, those are the poles, okay? And so one can be complete darkness, one can be complete light, while the equator is the exact same way. One side can be complete darkness while the other side is complete light. Okay, following? Now, with that, if the sun is directly over one of the poles, that pole is experiencing summer while the opposite is experiencing winter. Now, if the sun is directly over the equator, then it is experiencing spring or fall, and that's just really cool to me. But if you're in kind of like a summer month, then what happens is the planet appears more of this greenish hue. But if you're in one of the kind of like spring or fall kind of seasons, then what happens more so is it's more of a bluish color than anything. And Uranus actually has a lower gravity than Earth, with just 88% of Earth's gravity on Uranus. And so it would not be too bad to actually stand on Uranus, other than the temperatures, the wind, and just the horrible conditions otherwise. On the night of September 23rd, going into the morning of the 24th of 1846, 3 astronomers named Johann Gottfried Galle, Urbain Le Verrier, and John Couch Adams discovered Neptune. It was due to Johann Gottfried Galle's observation of the actual planet that we were able to fully confirm its existence, while it was due to Le Verrier's mathematical calculations that even suggested it in the first place. Now, Neptune's atmosphere is comprised of a variety of different chemicals, including 80% hydrogen, 19% helium, 1.5% methane, along with trace amounts of water, ammonia, and nitrogen, and that's what gives the planet its distinctive blue color. And due to the axial tilt of Neptune at 28.32 degrees relative to its orbit, there are seasonal changes, and each season takes roughly around 40 years on Neptune, while an entire Neptunian year is 165 Earth years. But just one singular day is 16 hours. Now, the temperatures on Neptune can reach negative 353 degrees Fahrenheit, which is equivalent to negative 214 degrees Celsius. And there are storms known as great dark spots that the winds get the worst that there are in the entire solar system, with ranging upwards of 1,200 miles per hour, which is insanely fast wind speeds. And most people believe that Neptune is this deep azure blue color, but in fact, its true color is more of this pale greenish blue color. It's a lot more like Uranus than anything, because whenever a lot of the photos that a lot of people would see were taken, they were high resolution to see better views of the atmosphere of the planet, not anything else. And so the actual true color of Neptune is kind of this pale greenish blue rather than a deep azure blue. Now, Neptune has 14 known moons, including Proteus and Triton, along with the fact that Neptune doesn't have too much of a different gravitational pull than Earth. In fact, it's only 1.14% Earth's gravity, meaning it's really not much more than what we have here.